Hi everyone, Mr. Lee here. In this video, we are going to use Newton's second law of motion in order to help explain Newton's third law of motion. So just to remind yourselves, remember Newton's second law of motion is F equals ma. The third law of motion is for every action force, there's an equal but opposite reaction force. Okay, so let's take a look at this problem. This problem says a box of mass 20 kilograms, so I'm going to highlight that, is right next to and touching a box of mass 30 kilograms. A force of 200 newtons is pushing the box of 20 kilograms to the right. Important. What is the system's acceleration if the system consists of both boxes? Okay, so whenever they tell you the system, it is very important to identify that because that will help our scope of the problem. Okay, so like all good problems, it is good to start off with a drawing. So I have here a 20 kilogram block and a 30 kilogram block, like so. I'm not going to draw the vertical forces for this scenario just yet. Okay, I will do that later. But now we are going to draw the force of 200 newtons, and this 200 newtons is pushing this 20 kilogram block to the right. All right, so I'm just going to do that up above. Okay, to indicate that this force is pushing this entire system to the right. Okay, so with this being said, if I were to create Newton's second law problem, F is equal to the system's mass times the acceleration, and we're looking for the acceleration of the system. Going to divide both sides by the mass. I'm taking a couple of mathematical shortcuts here. I hope you don't mind. But we would get this form of the equation. So the system's acceleration is equal to the total amount of the forces divided by the mass. According to this problem, the system has a total force of just F1, okay, divided by the system's mass. So that would be 200 divided by the system's mass. Now you might be noticing, Mr. Lee, you're saying the word system a lot, and you're right, because the system consists of both boxes. So instead of writing 20 or 30, I'm going to write 20 plus 30, which is just 50 kilograms there. And therefore, we math, the acceleration will therefore be 4 meters per second squared. Okay? All right. So we know that the system is accelerating at 4 meters per second squared. So if I were to ask you, how much, like if we were to draw a free body diagram for the 20 kilogram box only, we're now able to do so. So here's the 20 kilogram box. We know that it experiences a force of 200 to the right. Okay. We also know that there is a normal force, force of gravity down below, right? We could do that 20 times 10, which is 200. This is equal to that, so 200, because there's no other forces in the y direction. The two will equal to each other. And then we have this mystery force. Okay, I'm going to do that in red. Now we know that there's a mystery force because of the following. If we were to take this piece of information, so we know that both boxes are accelerating at 4 meters per second squared, and we put that in to Newton's second law, F equals ma, all right? We know that if we're looking at just the 20 kilogram box, the mass is 20, and we know that it's accelerating at 4 meters per second squared. So what this shows us is that the summation of all the forces is equal to 80 newtons. Ooh, okay. So I'm going to call this F1. I'm going to call this F2. So that must mean that F1 plus F2 is equal to 80. All right. We know that F1 is 200 plus F2 is equal to 80. And if I subtract 200 from both sides, we get that F2 is equal to negative 120 newtons. And that is our leftward force. 120. Okay, if this is, what was it? F1 is 200. I wrote it down. Okay, so that means that even though this box is feeling 200 newtons to the right, overall, it's only feeling a total force of, right here, 80 newtons, because that's our summation force. Okay, all right, so what does this mean? Where did this 120 come from? So if we take a look at the diagram, we see that this 20 kilogram is attached to and touching this 30 kilogram. So that means when this 20 kilogram box is pushed into and shoved into this 30 kilogram box, this 30 kilogram box, okay, that's the contact point, is pushing back with 120 newtons of force. So according to the third law, if the 120 newtons of force is being pushed into the 20 kilogram box by the 30 kilogram box, that must mean that the 30 kilogram box is being pushed in the opposite direction, so that would be to the right, with the same amount of force, which is 120 newtons. Okay, I'm going to draw the other free body diagram parts. So we have F of N, and we have F of G. If this is 30 kilograms, 30 times 10 gives us 300 newtons, and there's no other forces in the y direction, so that'll be also 300 newtons. Okay, so is there, I'm going to do this in, I'm going to do rainbow. Is there a unknown force to the left? Okay, this is how we can tell. By using Newton's second law. F equals ma. We know that the mass of the box is 30 kilograms. And from the math from right here, we know that the box, the 30 kilogram box, is accelerating at 4 meters per second squared. So 30 times 4 gives us 120 newtons. So that must mean that all the forces in the x direction must add up to 120. So would you look at that? We have 120 right there. So the question is there a force pushing this box to the left? And the answer is no, because this math states that this 120 newtons of force is the only force in the net force, okay, that 120. So that's pretty cool, right? So the biggest difference between the 30 kilogram and the 20 kilogram box is that we know that there is an outside force. I'm going to highlight that. And that outside force was the 200 newtons. That's where we got that. However, if we were to look at just the two objects, the system, we can see that they share the 120 newtons right there and the 120 newtons right there. The reason why there is nothing pushing this box to the left is, well, the problem doesn't say so. There's nothing pushing this 30 kilogram box to the left. Now, if there was friction, there would be, but the problem doesn't say so. And so we just proved that the third law exists. All right, I'll see you next time. Bye-bye.